Okay, let's have our first class. So this is exam 1, lecture 1. We're going to talk about is introduction, the history of microbiology. So here comes the first question. What is microbiology? Okay, what is microbiology? Obviously, we are talking about science of microorganisms. And we will get to what is microorganism real quick in a couple of seconds. So we're going to talk about what is the science behind that. In this class, you will learn is characteristics, of microorganism, and you will learn numeration, which means how many bacteria there. And you will also learn identification. And the last one, we will talk about applied microbiology. When we talk about all these things, we basically need your biology knowledge, biochemistry knowledge. We'll need you some genetics knowledge. These are the basic things we need. The skills, little bit of physics, little bit of math, and don't forget a chemistry. These are very comprehensive section for the microbiology. Okay, so just let you know at the beginning what it is, what are they talking about. So that's the first question, is what is microbiology, which means the science behind microorganism. Okay, now we move on to the second question. What is microorganism? So let's talk about this. Well, right here. Microorganism. Okay, how to understand this terminology? I usually do is split right here. So micro and organism. What this means? What micro means? Very small. Is that right? Very small and tiny. How small it is? So we say, yeah, you can see it. Too small to see by, we call naked eye or aided eyes, because they are very small. Can you guess how small it is? Majority of the time is less than 1 millimeter, most of the time. But there is some of the exception. Okay, what are the exceptions? Did you ever have a bread, you eat it, then you left it in your dorm on the bench, and a couple of days you forgot, you said, I'm hungry today, I'm gonna eat it. What you find? It started to turn green, is that right? What's that? It molds there. How about molded grape? Or molded bread? This is exception. Okay, some of them are exception. Okay, so that's micro means. So since it is too small to see by naked eyes, what we need to do? We need a tool to do the observation. Is that right? What's a tool? Microscope. Or we call it a microscopy. Okay, what are the microscopy we know? There's a light field microscope. There's a dark field microscope. There's a laser confocal microscope. There is an electronized microscope. All kinds of things with modern technology. Using microscope, we need to know, we will know the morphology and the characteristics of the microorganism. That is the first thing we get to have the impression of the microorganism. Okay, so that's something about the micro. Okay, what is organism? This is, you can understand, is live body. Okay. There's a life there. Organism is a life. With a very tiny life, you can understand that. Except for some of the mostly the brain. Okay, now here is something I want to mention. Do you know how many microorganisms in the world? If we really to do a research or do a survey, how many? 10 to the 30s. So millions, trillions, billions, so many. You can't even count. How many we really know? How many we really recognized and researched? Less equal than 5%. Okay, which means there is a 95% of microorganisms we don't even know it, which means they are unknown. That's part of the reason there is something bad bugs like a black plague in 17th century in Great Britain, killed a lot of people. There's the Spanish flu comes out. There's the COVID-19 comes out, and also the research saying in the future, maybe every 15, 20 years, there is some very harsh, harmful microorganism going to come out, and we don't even know it. Because even with the modern technology, we only know about 5%. There's a 95% around this giant number we don't even know it is. That's why it happens all the time. There's lots of the public risks, organisms, microorganisms comes out. Okay, so this is something talk about a microorganism. Now the next question will be, what type of the microorganism? Can you give us some of the examples? Yes, of course we can give you some of the examples. Everybody knows bacteria. Is that right? Everybody knows bacteria. So for example, you know E. coli. And I have a joke before, I said, even you failed AEM 341, come out of the classroom, maybe 30 years later, you're still going to remember when bacteria is E. coli. Everybody will remember. And then you know that like salmonella. So if you look at the news, the Department of Agriculture, Food Safety Inspection Service, we call it USDA FSIS, will be declare salmonella is zero tolerance in breaded chicken products. That gives a lot of challenge for those poultry processors. So you buy a breaded chicken nuggets, frozen, it is not well cooked. Used to be allow you to have a salmonella because they expect you to cook it. Right now, they require you to zero tolerance, which means they not allow one single cell of the salmonella there. And you also maybe heard about listeria. Okay, we are going to mention these later on. So that's bacteria, you know about it. What else do you know? Do you heard about fungi? Yeah, you heard about fungi. Okay, what are the fungi? What are the two examples of the fungi? Molds and yeast. Mold, we already mentioned about that. You have a bread, spoiled bread. At room temperature, put on your dorm table for like a week. It becomes green. Because at 25 degrees Celsius, the flavor it grow. So it's a mold. How about yeast? Yeast growth temperature is usually 37 degrees Celsius. You like yeast, we like yeast. Do you like a beer? Do you know the beer brewing process? They need yeast. Saccharomyces cerevisiae is the beer brewing yeast. We need yeast to do that. Okay, that's fungi. What else? Protozoa. Is that right? Or we call it, we don't talk about this one, we call it tastes. So there is a different category for that. There is a protozoa. There is called slime modes. There is called algae. So what is protozoa? Toxoplasma gondii. Is usually the protozoa is in the cats. So that's why the pregnant woman, usually they do not recommend you to have a cat because could cause like a still baby and a miscarriage. So that's protozoa. What is the slime modes? This one is very tricky. Slime modes usually have two different phases. It's a phase-defined protists. So sometimes it looks like a modes, and sometimes it looks like a protozoa. But why it is important? Because this guy, if you have a leafy there, for example, some debris, some dust, okay, we call it a dust, debris, all these type of environmental trash, we say. And this guy could eat it. How they eat it? They package it and they license it. So we call it's called engulf. Pretty much like a lysosome. Like your macrophage. If you learn in your immunology class, you already know macrophage is part of our white blood cell immune system. The slime modes in the environment pretty much like that. How about algae? This is usually contribute to at least 70 to 80% of the carbon dioxide and about like 10% of the oxygen in the environment. And this guy is usually photosynthesized, which means they use light, sunlight as an energy resource. Okay, so these are the examples. What else? If you look at here, there's another category called archaea. AEA. ARCHAEA. What is archaea? Archaea sometimes very similar to the bacteria, but they have a very special structure. It's a very special cell wall, cell membrane system. So for example, bacteria have a flagella for moving, for motility. Archaea has endoflagella. Just an example. Okay? So these are the examples. These four examples is basically can use a cell as a unit. So we call it cellular. And we all know that archaea and the bacteria, we call it prokaryotes. Fungi and protozoan, slime modes, algae, we call them eukaryotes. What is the difference between those two? You should be very clear in your biology class. If you're learning Biology 101, prokaryotes is open floor, is that right? Which means they have nucleic acids, but their cell machinery is not individual divided, separated. They all grabbed together. Eukaryotes, what means? EU means, that means true. So why it is true? Because all the cell machinery is separated by the individual cell membrane system, cell membrane bundle system. That's why it's called eukaryotes. Okay, so bacteria, archaea or prokaryotes, fungi, and protists is eukaryotes. So we say that this is cellular. Use cell as a unit. Then obviously we have some other things, which is acellular. So what are the examples of that? Nowadays, you know the first one is virus. Okay. COVID-19. COVID. What does this mean? Coronavirus ID 2019. What does the virus looks like? What is the structure of the virus looks like? Too simple. Okay, in the middle right is nucleic acids. DNA or RNA, and never both. Then they packaged with something. What is this called? That's called capsid. What is the major components of the capsid? It's protein. Now what does coronavirus looks like? There's some crown there. Looks like this. Then this crown will be shifted. That's why there are lots of mutation comes out. Now, once you see the virus structure is that simple, do you think it's easy to control? Seems like yes, it is. Is that right? But it's difficult. Why? DNA and RNA, whenever the chemical attacks there, they will generate lots of mutation. And you know that. That's why there is so many DNA replication, transcription, translation mechanism, or all different type of the microorganism. Everything is attacking DNA and RNA usually means nothing because mutation going to come out. Then they say, okay, how about let's attack protein? Yeah, it's a good idea we attack protein, but don't forget, our human being has protein. Is that right? Therefore, any of the antiviral medicine will have a side effect for you. They will be using only for the life-threatening situation. That is what traditionally they do. So what happened for the virus happens. There is only two things can do. One thing is develop antibody, antigen reaction, so will generate antibody. Antibody treatments. Okay, AB treatment. That is a very expensive. We'll talk about later on because you have to isolate the blood cell and to generate a rich blood cell antibody. And then you use it in human being for the clinical trials. Okay, so that's one of the methods. Another method is what we do. We talk about this all the time, is vaccination, which is a protection, which is a prevention methodology to do that. Okay, so that is for the virus. I just want to give you some of the introduction. We'll talk about that very detailed. Now, what else we have? Varroids. This is a guy, usually it is a single RNA. And that happens is in a plant disease. It's in Philippines. In 1996, there's a varroids happens in the flooding area. All those like banana trees has been damaged. So it's basically is a plant disease, a plant pathogen, we can say that. What else we have? Satellite. This is the one, I never see that before. We're not going to see in the lab. This is what they say is like some of the RNA is integrated into the protein. And I never see that before. Okay. We had nucleic acids. We have a protein. Most of these, we have a single RNA, could cause a problem. we have RNA integrated into a protein could cause a problem. They combine together has a problem. How about single protein? They also will have a problem. That's called prions. P-R-I. Did you ever heard about mad cow disease? Did you ever heard about Kulu? Mad cow disease, everybody knows. That is happened back in 1997 in Great Britain. The cow has some of the brain disease. They transmit it to the other person, transfer to the other person, cause a big damage of the cow industry, meat industry. And the problem is not a bacteria, not a virus, it's a prions. It's a very special protein. The only way what they can do is kill them and deep bury it. That's the only thing they can do. Okay, what is the Kulu? That some of the prions happen in the human being is a muscle relaxation, which means you're going to have to laugh in the whole day. Think about if you laugh here, laughing about an hour, what's going to happen? So these two is caused by the protein. Now, all these are examples of acellular. Okay? In this class, because we had a limited time, we're not going to talk about everything in very detail. So in this class, we will be focused basically on bacteria. Typically in the lab, we will use E. coli as an example. And sometimes we will do enterobacteria, Bacillus, Staphylococcus aureus, all those type of things. So we focus on the bacteria. We will mention about the fungi. So I had a section which is talk about the broad-based body of the fungi. You will see in your first lab under microscope to see the Saccharomyces cerevisiae, what it looks like. So we will mention that. Protozoan, I believe you have other classes, but we're not going to do it. Archaea, environmental microbiology, Dr. Amber Morris teaching that, you will do in those classes. We don't talk about archaea. Virus, we can do it here. Why? Our lab is certified as biosafety level 1. BSL1, we cannot do the virus. The virus, you have to reach biosafety level 2 and even biosafety level 3. So we're not going to touch virus at all. We're only going to do some of the test. Okay, I may give you to buy some of the coronavirus, like COVID-19, the antigen test. We can do some testing in the lab if later on when we move to the clinical section. Okay, then let you know about get some practice by yourself. You pretty much did all the time by yourself, but we can do it later. Okay, so this is what we have for our microorganisms. So basically is this slides, and I explored to talk about that. So there is one thing I haven't mentioned for the archaea. There is one thing we call it's methanogens. This is we generate a methane gas. That's a bacteria generated methane gas. Now most of these archaea, algae, all these things we call it an environmental microorganism because most likely they live in the wildlife environments. Okay, so we will talk about these, some of them later on. What's the classification of microorganism? Very complicated history. There's a 5 domains, 3 domains, but we make your life easy. It's based on the isolation of ribosome RNA or RNA. Then to calculate the genetic distance, we can categorize microorganisms into 3 domains. It's very simple. Bacteria, archaea, and eukarya. This bacteria we mentioned is a true bacteria, not those older ones. Okay? Eukaryotes and archaea. Here are some of the examples. So basically, we have 3 different 3-domain systems to classification of the microorganisms. Some of the slides to introduce some further stuff. When we talk about microorganism, we always say it's bad, it's really bad. Yes. If you eat undercooked beef products, ground beef or beef steaks, what are you going to do? Sometimes diarrhea afterwards. Yeah, it causes diarrhea. E. coli will cause urinary tract infection. What's the first symptoms of urinary tract infection? You're always going to go to the restroom and you're feeling burning during the pee. Is that right? So that's bad. Salmonella, food poisoning, we already mentioned, it's a major pathogen in the poultry products. Viruses, we don't need to emphasize that one. It's talked about too much. So it's really bad. But does that mean it's always bad? Yes, look at here. Bacterial infection of fish. That's maybe the vibrio. Tomato, blossom, and the lot. Look at this stuff. That may be cause ammonia from the soil. Conjunctivitis. Now be careful when you have this guy happen. It's not really, it's only a skin problem. It may be the sexual transmitted disease. The chlamydia could cause conjunctivitis of the eye. This guy you always know, strep throat. Right now it's all COVID-19 and COVID-19 tested positive negative. Before that, the most excuse I will get from the email from all kinds of students will say, I'm not going to go into your class tomorrow because I have a strep throat. And I believe it. It's not a joke. I believe it. Sometimes happens. Streptococcus pyogenes. That's what looks like a strep throat. But of course, not everything is strep throat. Most of you get is a cold virus. I can tell you. Strep throat is really a serious problem. It's going to be a very deep infection. We will mention this in the examination 3. Okay, but tell you what is strep throat looks like. So really bad. But does that mean it's always bad? Not really. Some are really good. Do you like beer? Do you like wine? Yeah, you like it. Alcoholic beverages is going through fermentation. Okay, what this one looks like? Is that called ale? A-L-E. Another one, A-L-A-R-G-E. Is that called lager? Yeah, that's a beer. Red wine, white wine. So that's fermented products. We will mention this a little bit in our examination 3 when we talk about fermentation. Antibiotics, penicillin, amoxicillin, what is that? Mold. Yeah, come from the molds. The metabolic come from the molds to killing bacteria. That's called antibiotics. Insecticides. Do you like all this stuff? Fermented products, yogurts, cheese. Which bacteria are doing these things? Lactic acid bacteria. So, we call these a beneficial bacteria. So bacteria is always good. Sometimes, not always bad. When we talk about microorganisms, don't always think about it's really bad, it's really hurt you, not really. Lots of the time it's really good. Okay? So, start from here, we finish talk about is the introduction of these microorganisms. Then we're gonna move on to a little bit of history. So I will finish these slides and we will off today's class. Because we talk about the COVID-19 these days, then the CDC have worked really hard with different companies. We have a Pfizer, Moderna, Johnson & Johnson, all have the vaccine. Is that right? I asked you to do the vaccine. Did you do the vaccine? Yeah, lots of do. I have 2 vaccines and 1 boosters. I wouldn't want to do any more because I don't think we're going to come back to the coronavirus and have a shot every half a year. Is that right? That's ridiculous. So, what is a vaccine then? V-A-C-C, vaccination. So first thing, what is that terminology comes out? This terminology is named by Louis Pasteur, a great French microbiologist. We will mention his contribution later on. In order to memorize Edward Jenner, a scientist, a medical scientist from Great Britain, Louis Pasteur named it vaccination. So what it means? What is VACCI means? This is in Latin words, which means call. Then you're going to have a question. How come you come out that call? What are you talking about? Because long time ago, there is a very damaged virus called smallpox. Once you have a smallpox, it is your immune system will be completely damaged. The bone marrow, you cannot generate a new blood cell problem. Even you recover from the smallpox, when you have a big sequela, which means the disease following recovery, your face is like all different kinds of the lesions. So what happened is, this face looks like, let's say that human being like that, okay? We just say this. If you recover, what will happen? This is what you recovered with smallpox. The only thing they can do in the older time is put you isolated in the island. Look at the movie, Shut Island. That's what it looks like. Okay, how are we going to combat it? At that time, there's no way to do antiviral drugs. That's very late. What they do? Edward Jenner find there is some of the ladies working in the farm, the cow farm in the Great Britain. They got a very mild symptom. We call it cowpox. So what does the cowpox looks like? If you want to draw this, the cowpox looks like his arm. They find there is a lesion like this. So they take out of the lesions, and then to generate the vaccines, the chemicals is to inject it to the boy there. Then the boy later on also contaminated with smallpox, but that boy is survived. That is what vaccination comes out. Because the first time when they do, is coming from a lady who has a cowpox. The lesions from the arm, they make those chemicals. That chemicals can prevent smallpox, smallpox cause any of the damage. So that's why we want to remember Edward Jenner, we name it cow. Then use the Latin word is VACCI. That's why we call it a vaccination. That's what it originally comes. Okay. Now, Louis Pasteur for itself, he also did a very good contribution for it. He had a boy, which is 9 years old, named Joseph. One day has been bitten by a crazy dog. You know that what's the name? Rabies, is that right? What he did? He made the chemicals of the rabies coming from the previous patients. Isolate. The boy bitten by a dog. In the next 10 days, he injected the boy with his made vaccination of the rabies intensively for 13 times. And finally, this boy survived. You know that when you have a bite by a dog, you need to have a rabies vaccine immediately. That's the only way you can do, otherwise you're completely died. Now, there is a rumor says in 2030, the United States is going to be concave this disease. I don't think so. It's not looking that way yet. Okay? But I just tell you, for the vaccination is the first line, is the protection of the virus attacking people. And we want to memorize Edward Jenner. That's why we named them vaccination. Okay? So that's all I have today. And we will continue to talk about history when we're back.